Wanting out of class, just do whatever you want to do. Be whining about your grade again soon. Did I push the start? I think I did. Yep. All right. 3 types of variations that we got to deal with. And we've done these in Algebra 2. It's been a while, though. This is something first period didn't remember very well. First type is called direct. And there's going to be keywords for you. And it'll say something varies directly as the other one. What we need to know about direct variation is that it deals with multiplication. Our normal formula that we're going to write is y equals k times x. Direct deals with multiplication. Okay, we could also have some powers on our x if we wanted to. Now these problems are, let's put it in for any power. These problems are going to have to do with word problems. So you can switch those letters to stand for whatever the word problem stands for. But anytime when you read y, can I help you? No. Go on. Hey, go on. No. Get out of class. Go. When I read a problem, it will say something varies directly. So whatever letter you're going to choose, you write that letter equals K. K stands for constant. I don't know why they use K instead of C other than they're dumber than me. Anytime it says constant in math, that's your K. So I don't know. The varies will always have a constant, so you're always going to use a K. So a couple of these problems here we've got. This first one that we're looking at, it says we got a deal about the springs that are stretching. It says that the distance a spring stretches is directly proportional to the force applied. Okay, so the distance the spring stretches is directly proportional to the force applied. That's how you would write your equation. And that's the only hard part of this, is reading the sentence and then writing the equation. So we read the distance varies directly as the force. Varies directly means you multiply something by K. And then you pick whatever letters you want. I use D for distance and F for force. So what we got in this particular problem, it says a force of 150 newtons stretches a spring 8 centimeters. Okay? But what if we had a force of 400 newtons? How much would it stretch the spring? And this is the type of problem that you'll have the most. And what you do on it's pretty simple. You take the stuff where you know everything and you plug it in and solve for K. So then you can go with the K to the part where you got something missing and figure that out. Okay? So we've got distance is 8. We don't know the constant times the force is 150. What would we do to solve that for constant?
Divide by 150.
Divide by 150. Going to be a little bitty number for you here. What's 8 divided by 150?
0.053.
Not very big at all. Okay, so now we can take that number back over here and plug it in and solve for that. Now, common sense on a lot of this stuff. Here we had 150 newtons pulling and it pulled the spring out to 8 centimeters. But we've more than doubled that. So what should we expect our distance to be in relationship to 8? We're pulling in with a lot more force. It's going to be a lot longer, isn't it? So I should expect something a lot longer than 8 centimeters. Let's check it out and see. Distance is equal to K times force. So what's 0.053 times 400?
21.2.
So it'll be 21.2. I don't remember when I say centimeters. I don't remember what I said.
Yeah.
Thank you, Chase. Good. Not too shabby. Do another direct one. We're just going to do a couple of each kind. We got 3 types. Direct's the first type. All right. This one we got talking about skydiving. Says the distance a body falls from rest varies directly as the square of the time it falls. Okay, so we got to write the equation out of that. The distance that a body falls at rest varies directly as the square of the time. That's just like the parent one that we wrote down, y equals kx squared. We just use d and t to stand for distance and time. Same thing. Okay, so here's the stuff we know about skydiving out of this particular. The skydiver falls 64 feet. Write my units this time. In a time of 2 seconds. How far will they fall? So we're solving for distance. In 8 seconds. Okay, so it's dropping a lot longer here, 6 more seconds. So we ought to expect her to fall a lot farther on that. First thing you're going to do is use all your completed stuff to solve for k, and then take your k to solve for your incomplete. Okay, so I got 64 equals k times 2 squared. That's an easy one to solve. You know your 2 squared, so you got 64 is 4k. What's your constant on this one? What's k? Wish I'd have given you all an $80 calculator to figure it out. Oh, wait, I did. Thank you, Kirsten. K is 16. So now take your 16, you got your time, use that to find the distance. And this is just like a distance equals rate times time problem here. You can say, well, they're falling at, you can make that conversion. Distance is 16 times 8 squared. 8 squared is 64. So you're looking at 64 times 16. How far did our skydiver fall after 8 seconds?
Hello, Miss Wright?
Yes.
Can we see page Rutledge in the library, please?
When we finish with math class.
Okay, thank you.
Bye-bye. What's 64 times 16?
1,024.
1,024. I started to write feet already. Feet. I don't know how far they jumped from, but I hope it hadn't squashed yet. That's a long way to fall. I don't know, how high do you go when you skydive? Y'all ever done it?
I think it's usually just around 20 feet.
Yeah, it's usually 250 to 300 feet.
Phew, that person is under the ground. Thanks. Oh. Splat. Alright. Direct connects with multiply. Inverse, that's the next one we got. Told you there were 3 types. Inverse connects with division. You could throw power if you wanted to. Direct with multiply, inverse with divide. Questions will be the same. It'll say varies inversely, so you'll start off with something equals k over. Alright, so let's jump in. This one's kind of a weird problem. We did it this morning. It says the manufacture of a certain medical syringe, the cost of producing the syringe varies inversely as the number produced. I got this? So the cost varies inversely as the number produced. All right, here's what we got here. It says if 10,000 syringes are produced, the cost is $2 per syringe. What will the cost per syringe be if 25,000 are produced? Now this confused first period a little bit, and it'll confuse you if you've never ordered like a big number of stuff. Lots of people in first period said, well, I'm going to be ordering more than double, so it's going to cost a lot more. And yes, to the person buying them retail, it will. But we're talking here about the cost of producing them. So you look at if you've ever ordered shirts for a big group or something. If you order 10 shirts, how much do they cost per shirt compared to if you order 50 shirts? How much do they cost per shirt? Usually a little bit cheaper when you buy a bigger bulk of something, right? So that's what we're going to see here. So we should expect our cost per syringe to go down because we're making a lot more of them. It doesn't cost as much to make when you make a lot more of them because you've already got the molds or whatever. I don't know what you got to do to make a syringe. That's kind of weird to me, I guess. Hospital people know about that. I don't know. Pharmaceutical, is that what would know about that pharmaceutical fuel. Oh. All right, we got to take the stuff we know. $2 is equal to K divided by 10,000. That's an easy one to solve. If your K is being divided by 10,000, you're just going to multiply by 10,000. So that gets you 20,000. Now take that to figure out the cost if we're going to produce 25,000 of them. 20,000 divided by 25,000. Can you do that mental math there?
One of them.
Take a 5 out. 4/5, which 4/5, if you make 4 or 5 on a quiz, that's an 80%. 80 cents each. And you could have did that on your calculator if you didn't get the mental math. It's okay. Okay, one more inverse one, then we'll go on to joint. This one we're orbiting the Earth. Got that? Alright, it says the weight of an object above the Earth varies inversely as the square of its distance from the center of the Earth. The weight varies inversely as the square of the distance. That's the hardest part. I've said that 5 times already today. Writing that model is the toughest part because they just give it to you in a word problem. Once you get that written, it's just plugging stuff in. Here's what we got. A space shuttle in an elliptical orbit has a maximum distance from the Earth of 6,700 miles. At that, well, we don't know that yet. Yeah, we do. If the astronaut in the shuttle at that time weighs 57 pounds. Okay, here's what we got to go with it now. The minimum distance from the center of the Earth is 4,090 miles. How much will the astronaut weigh there? Alright, so let's think about it, see what kind of answer we expect. Would we think our weight's going to be more than 57 pounds or less?
Where is the top one coming from?
6,700 miles away from the center of the Earth. This one's 4,090 miles away from the center of the Earth. So this one is closer to the Earth than that one.
So it'll probably weigh more?
Good. Closer you get to the Earth, the more the Earth's gravity is going to get on you and the more you're going to weigh. Very good. If we could all live here, we would not be very heavy. Alright, so we're going to take this far away stuff, plug it in, get a K, and then use it to find our closer stuff. So 57 pounds is equal to K divided by, this is going to be huge, 6,700 squared. Alright, to solve this for K, it's being divided by 6,700 squared, so you got to multiply by 6,700 squared. So Mason, I'm definitely going to need some help here. 57 times 6,700 squared.
Yeah, I can't read those.
Well, just give me some, I'll write the numbers as you read them.
Okay, 2, 5, 5, 8, 7, 3, 0, 0, 0, 0.
730,000.
Yep. Okay, so now we're going to take that K and we're going to plug it in here to figure out how much the astronaut will weigh there. So the weight will equal 2,558,730,000 divided by 4,090 squared. So calculate some, push some buttons on that. How much is our astronaut going to weigh at that point? You just round it to the nearest whole pound, it'll be all right. 153. So that makes sense on what Keston said. Weighed a lot more the closer you got to the Earth. We could all like,
Approximately 95.
George Jetson car and that'd be fun. Fun. Alright, so we did direct, and what operation do we link direct with? Very good. Mason multiply. We did inverse. What operation did we link inverse with? Divide, hot dog, Mason. Now, when we do joint, the pattern that we're going to write down for joint variation, B-R-I-T, is going to be more than one letter. That's what we're going to start with. But we're also going to do one after we do more than one letter where it can be more than one operation, where we could have direct with multiply and inverse with divide. So we could throw them both in there. Okay? So we ready? Got it? Alright, so here's the first one. This one, we've got an interest formula that we've used in this math class and in Algebra 2 both a lot. Interest is equal to principal times rate times time. That's a joint variation because you got multiple variables in there. First period said what variables? Well, there's 4 there, knothead. I, P, R, T. What are you thinking? Anyway, so what we've got here, you know, the I is the interest you earn, the principal is what you deposit, the R is the interest rate, and the T is your time. So an investment earns $100 interest. So we've got an I of $100 at 5%. 5% would be 0.05 over 2 years. So our time is 2 years. Okay? Question says, what do we not know out of this? What's not given?
P.
P. Very good. We're going to find the principal, so I'll go ahead and leave that. Question says, but how much interest will the same principal earn? So whatever this P, it's going to be the same here. Will the same principal earn at 4.5%? Interest we don't know. Rate 4.5% is 0.045 over 3 years. Okay, so we got to use all this stuff to find the P and then plug that in to see what interest that would earn there. It's like we're shopping around 2 different banks and we want to know which one's going to give us the most interest. So I got I is 100. I don't know P. R is 0.05. T is 2. T is 2, not T. T is 2. T for T. T for 2. Okay, what will we do to solve for P?
Oh, should I divide by the 2?
Good, yeah. Now, well, let's just divide them both at the same time. Can we handle that?
Yeah.
I say we can. Somebody might mess up pushing buttons. I need to know what 100 divided by 0.05 times 2 is. I'll cross my fingers that you push some good buttons for me.
1,000.
1,000. Okay. Did you get it, Mason?
Yeah, that looks right.
Put this whole bottom, go back up there and highlight it, and we'll work on it. Hit enter so you can bring it down and work on it. Now move over here after the divide and add a parentheses right there. Hit second, the blue button, insert, and then add a parentheses. Now move over to the back end and add another parentheses. Put that whole thing in the bottom in a parentheses so it doesn't do order of operations. Now hit enter. There you go. Alright, so we're investing $1,000 and at this bank that earned me $100. So at this bank, if I put the $1,000 in the bank and don't mess with it, I got $1,100, right? Okay, now let's take that $1,000 to this bank and see what it'll make us. So, interest is P, which is $1,000, times rate, times time. Gotta leave it in there an extra year, but what? I mean, that's no big deal. Not do anything with it. What does that get? 1,000 times point. Say again.
135.
Ooh, this bank earned me $35 more, so I would pick it.
Yep.
Not a lot, but still, if it's 35 more, it's 35 more.
Wait, you put 135.
Yeah, that's what she said.
Oh.
Because, good question. Because this one was 100, so 35 more. Good deal, good deal. All right, I got one more where we combine some stuff. We got what we need. All right, so this one's about our BMI, and this always cracks me up when they do the BMI test here. Like little bitty skinny people will come back and they told them they're obese. I don't think they know how to measure it, right? But anyway, BMI, body mass index, is used by physicians to assess a person's level of fatness. That's a good word. BMI from 19 to 25 is considered desirable.
Male or female?
That doesn't tell me. So there is different reading on both of them. You're right. So I don't know on that. This is the stuff we need here. It says BMI varies. Whoops. BMI varies directly. Where did I get it? BMI varies directly as an individual's weight in pounds, and inversely as the square of their height in inches. So we had both of them there. We varied directly as the weight, so we multiplied, and inversely as the square of the height, so we divided. All right, here's what we got. A person who weighs 118 pounds and is 64 inches tall has a BMI of 20.
5'4".
What would the BMI of a person who weighs 165 pounds and is 70 inches tall be? Okay, so we got to use all the stuff we know to find our K. Then we'll go back there and plug it in to find that person's BMI. Alright, so this one's 20, so based on that stuff we read, that would be desirable. That's between 19 and 25. It's closer to 19, so this would probably be a skinnier person. We got 20 equals K times 118 divided by 64 squared. Now, if I were you solving this, I would go in pieces. I would get rid of the 64 squared that it's being divided by first. So tell me what 20 times 64 squared is.
81,920.
Is equal to K times 118. Now I'm ready to get rid of that 118, so I'm going to divide by 118. And what we got?
694.2.
Okay, so now we're going to take this over here to this new person to find out their BMI. So we got B is equal to K. It didn't save me enough room there. B is equal to K times the weight, which was 165, divided by, was it the height squared? Yep, 70 squared. You got it? What would this person's BMI be? Say it again. Almost the 23.4. I'm gonna say about 23. That'd be all right. I think most of them they do in whole numbers. I don't know for sure. So that person is still in the desirable, but they're more towards the other end of it. All right. So the difficult part out of that, like I said now 8 times, is just writing the original equation. Once you get that, it's just plugging in and solving. Okay. All right, I'm going to write you one in words, and this is going to be what you're going to answer in your exit question. I'll read it to you, and then I'll hit the button to make your question go there. So look at that, the notes that I've made for you while I read the question so you know what we're talking about. It says over a specified distance, speed varies inversely with time. If a Dodge Viper on a test track goes a certain distance in 1/2 minutes, so there's where the time is 0.5, 1/2 minute at 160 miles per hour, what speed is needed to go the same distance in 3/4 of a minute? So there's the 0.75 time. Okay, so this is just exactly like the stuff that we did. I'm getting this question typed right now.
All those.
Since we're reading a speedometer here, you can round it to a whole number.
Okay.
I don't know of any that give you partials. All right, just showed up in mine.
Like 116.5.